Hi everyone, my name is Archna Gupta, and in this session, I am going to talk about optimal Canary deployments using Istio and how it scores over Spring Cloud and Kubernetes. Let's have a quick recap on what is a Canary release or a deployment. The idea behind a Canary release is that we expose a new version of a service only to a subset of users before rolling it out to the entire user base so that we can observe the new service's behavior for a while until we are convinced that it doesn't present any runtime defects. For example, you have a banking website and you are building a new feature, automated alerts. You may not want to roll out this feature to entire customer base of your bank. You may want to roll out this feature only to some particular subset of users, gather their feedback, make adjustments, and then roll out the final feature to all the users. Or you may be in a situation where you don't want to risk the entire traffic to a new application version. You may want only a subset of traffic to your new service so that you can monitor their performance and fix issues before you divert your complete traffic to the new service. There can be a multitude of scenarios where you would like to go with Canary deployments. Let's see how do we do Canary deployments in Kubernetes. Assume you have a service named Demo Canary, which is used by an external application, www.myapplication.com. If you want to roll out a Canary release of your service Demo Canary, this is what you will do. You'll create an identical duplicate deployment of Demo Canary service using same labels as the original deployment of this service and add some additional labels to differentiate between the deployments. Here I am using the label version with values v1 and v2 to differentiate between two deployments. You will have a service that load balances the external traffic to both these deployments. This service will have selectors that will only use the common labels between these two deployments. In our case, the service will use labels app and env. After ascertaining that the Canary release is fine, we can increase the traffic percentage to the new deployment gradually until we move the entire traffic from version 1 to version 2. Now remember, we can't use auto-scaling anymore because it's now being done by two independent autoscalers, one for each deployment. Whether we use Kubernetes or any other container management platform like Docker, Mesos, or anything, all of them use instance scaling to manage traffic. The only way to manage the amount of traffic that a particular version receives is by controlling the replica ratio. If you want your Canary release to receive only 10% of the traffic, you have to deploy at least 10 replicas in the ratio 9:1. Imagine how many replicas you will need if you want your Canary release to receive only 1% of the traffic. Another limitation with all these platforms is that they only support traffic percentage based Canary approach. What if you want to roll out the Canary release for only particular users? For example, you may want to roll out a new accounts report only to the admin users and not to the general users. In the next few slides, we'll see how the Canary release can be rolled out to a particular set of users. Before we do that, let's see another problem that we have if we are trying to canary release the services across multiple application layers. Let's extend the scenario we have so far. Assume I have another microservice called my data service for which I want to do a canary release. Both the services, demo canary and my data service, are bound such that I want traffic to flow through either version 1 of both these services or version v2 of both these services. No traffic should flow from demo canary version 1 to my data service version 2. And no traffic should flow from demo canary version 2 to my data service version 1. How can we manage this in Kubernetes? Of course, there is session affinity, but its scope is limited to that connections from a particular client are passed to the same pod each time. It doesn't ensure that the first time requests are passed between the compatible versions of the pods. Now let's see how we can achieve a multi-layer canary deployment using Spring Cloud-based microservices. Let's ignore the platform where the application is deployed. It can be Cloud Foundry, Kubernetes, OpenShift, VMs, anything. We have Spring Cloud Gateway, where we can do header or cookie-based routing to route the traffic for admin and non-admin users to the right version of demo canary service. However, when we are routing from demo canary service to my data service, normally we use ribbon load balancer and Eureka to get the destination service instance, which in this case can be any version of my data service. Of course, we can route to the appropriate version via code changes, but that's not the option we are looking here. So what's the solution? What we can do is to have two identical deployments like blue-green deployments, and we need to use Spring Cloud Gateway to split the user's request to a specific application based on headers sent by the client. So all the non-admin users are routed to the green deployment and all the admin users are routed to the blue deployment. Here, each deployment has its own Eureka server and each version of service is deployed on different Eureka servers. So version 1 demo canary will call version 1 my data service and version 2 demo canary will call version 2 my data service. Imagine an application with 200 services and we want to roll out canary release for only 4 to 5 services. Is it even a practical approach to spin up the blue-green environments with 200 services each in such cases? This is where Istio virtual services and destination rules come to rescue. Let's see how this can be achieved using Istio. Here we use Istio Ingress Gateway, which is routing the traffic to a virtual service for demo canary deployment. The demo canary deployment for version 1 and 2 both are exposed as cluster IP services using common labels, just the same way we saw earlier using Kubernetes. With Istio, we create a virtual service that has destination rules based on request headers to route traffic for non-admin users to version 1 pods and admin users to version 2 pods. When demo canary pods want to connect to the correct version of my data service pods, they will again connect via a virtual service. Demo canary pods will send requests to the virtual service host as if it was a single entity, and Envoy then routes the traffic to the different versions depending on the virtual service rules. We just saw how it can be so simple and efficient to perform Canary releases using Istio compared to Kubernetes and Spring Cloud. That's all for this session. Please post if you have any questions for me, and I will get back to you. Thank you.